In a high-tech age, you will hardly expect someone following in the footsteps of Marconi and Edison in this kind of rural setting. But Dr. John Pond is a physicist and consultant who works from home at his farm in Mitchett near Farnborough. He is just as likely to be found in his laboratory developing his most recent project, the use of sound for ferrying objects by remote control, or out on the farm, running the family business.
I grew up on my father's farm, and I always had to milk the cows, both before going to school and after I came back again. I'm glad you're doing it today rather than me. But I was always interested in physics, science, and I went on to Southampton University, where I studied physics. Then I did 10 years full-time research. After that, I was a lecturer for 10 years. Then, unfortunately, my father died, and I had to take over running the family business. I've always been interested in the things sound could do. I did my first experiment when I was 9. I put a loudspeaker in the cowshed to see if playing music to the cows could increase their milk yield, and it actually worked. The music relaxed the cows and they let down their milk more easily. Since that time, I've become increasingly fascinated by the effects of sound. One of the marvellous things about sound is how something as elegant and gentle as this passage from Beethoven can be so soothing to the ear and yet carry with it an extraordinary power, enough, as we saw earlier, to shatter a wine glass. Believe it or not, sound can even damage a tough metal surface like this. So what, you might wonder, is the connection between a pitted propeller on a motorboat and Beethoven's music? Perhaps we had better start with music, a pleasant, familiar, and clearly audible example of sound. Beethoven's music is a combination of sounds which have various features: tone color, rhythm, harmony, and so on. But the vital thing I want to emphasize here is its mechanical nature. Sound is mechanical vibration. That's how we hear it. The sound travels like waves on the sea. It vibrates the eardrum, which turns it into an electrical signal for the brain. Beethoven's external ear was damaged, and he had great difficulty in hearing sound coming through the air. So occasionally, in order to experience his own music, he used a stick, and the stick transmitted the vibrations of the piano frame directly through, in fact, to the roof of his mouth. I've got a stick here. Let us see how this works. It's amazing how well the sound came through the stick. Holding the wood firmly pressed against my upper jaw, I could feel the vibrations from the piano. Mark, will you fix the stick to the piano, and Edward, will you plug in and switch on the recorder? Together with my sons, Mark and Edward, I set up an experiment to prove that travelling vibrations could be faithfully recorded as sound at the other end of Beethoven's stick. Okay, looks all right. The stick is connected to the stylus of a record player, which feeds into a cassette recorder. Please note that no microphone is involved in this experiment. The vibrations travel through the piano, through the stick, through the stylus, and are recorded on tape. In fact, this is exactly how a record player picks up and conveys sound. This is the recording of Beethoven's music, a useful illustration that sound is nothing else but mechanical vibration, a first and significant step in understanding what happened to the pitted propeller. Sound is described by frequency, intensity, and loudness. The frequency is the number of vibrations per second. The intensity is the physical concentration of power in the sound. And the loudness is something else, how loud it sounds to us when we hear it. Loudness is measured in decibels. This is a sound level meter, reading in decibels. And if I measure my conversational level of speech, it ought to be about 60 decibels. Close to this orchestra, we have a loudness level of about 100 decibels, which is approximately 8 times louder than my voice, and naturally a sound of much greater intensity. In the audible range, any increase in intensity will bring about an increase in loudness. The energy of sound, just like electricity, is measured in watts. The power generated by this orchestra is about 25 watts. The biggest man-made noise on Earth came from the Saturn engines, which lifted the Apollo rocket to outer space. It was over 190 decibels. The power of the Apollo sound wave was about 100 million watts, strong enough not only to knock down walls, but to make it difficult for anyone to measure its effects without catastrophic damages.